I'm going to give you another example for the RSA algorithm, and let us do this example. Let me do this one. Yeah, for example, if a decrypted message, which is IAGN, this is the decrypted message, which is a secret message A, G, and N. Okay, this is a decrypted message or secret message. Secret message is given to you, and according to the public key, which is the public key is 7, which is 7 and 33. This is our public key, and we are going to determine what the private key will be here. So the private key, we are going to find D, and D should be between the 0, actually between the 1, and it has to be smaller than the 10. Okay, a secret message is given as IAGN, and public key is given, and we are asked for decryption of the secret message. Okay, now we are going to apply the same process. At first, step 1, let me change my color. At first, step 1, which is determine the P and Q, right? And as far as we know, this is E. If it is public key, this E, and this one is N. So N equals 33. So it means that it is multiplication of P and Q. And this P and Q should be prime numbers. And this will be 3 multiplied by 11, right? It is very easy to understand. So we can say that P equals 3 and Q equals 11. So this is the first step. This is the second step. And now we are going to find the Euler totant, which is our third step. The Euler totant, which is P minus 1 multiplied Q minus 1, which is 2 multiplied 10, which is 20. Okay, so N equals 33 and Euler totant equals 20. Now, step 4, E is given, which is 7 in our case. So step 5, we are going to find the D. So we know that D equals the inverse of E in modulo Euler totant. E multiplied E, actually, let us write to E as 7 multiplied by D equals 1 in modulo 20. So the D has to be, in our case, it says that D has to be one of them, which is 1, or not 1, it's 2, 3, 4, 5, 6, 7, 8, 9. That's it. So you check one of them, or one by one. But if there is no constraint for D, you know how to find the inverse of D in this case, right? You have to apply the Euclidean algorithm. So there's no need to say, or no need to make any constraint for D. Okay? So if I multiply 7 by 2, it will be 14. If I multiply by 3, it will be 21. So 3 we can use as decryption key as well. But let us check other ones too. it will be 28, the remainder will be 8, and the remainder will be 15, and the remainder will be 2, and the remainder will be 9, and the remainder will be 16, and the remainder will be 3. So the remainder will be 1 only in the case as d equals 3. So our private key, we found it as, let me do here, private key equals 333. This is N and this is D. Okay, now we know our secret message, which is I, A, G, and N. Okay, what is the number of I and what is the number of A and what is the number of G? Let me check. For I equals, let me check here. Oops. Yes, I equals 9. It is 9. And I equal A equals 27. And G equals only 7. And N equals 14. So okay, 14. 9 power of what? Which key we have to use for decryption? For the decryption, we are going to use private key. Yes, the D should be 3. So power of 3 and power of 3, power of 3 and power of 3. It has to be x1 in modulo 33. And for this one, x2 should be modulo 33. And this has to be modulo 33 too. And this has to be modulo 33. So here we are going to continue with 9 power of 3. 9 power of 3, and in modulo 33 it will be 3. And for this one, yes, so the other one is 27 power of 3, and in modulo 33 it will be 15. And for 7 power of 3, in modulo 33 it will be 13. For 14 power of 3, in modulo 33 it will be 5. So what is the letter for 3? It is C. Let me change the color. It is C. For 15 it is O. For 13 it is M. And for 5 it is E. So our message, our original message is come. Okay? So is there a question? So there will be only the 5 steps, and each step is very easy to implement. At first, you have to define the E, which is the public key. At first, you actually, if you try to encryption an original message, you have to start with the two small prime numbers, and with these prime numbers, you are going to calculate the n, which is our great model. You can say that. So we are going to use Euler total. It is used for determinant of the E, and also it is the determinants of the D. This Euler total is important for us. That's why. And then after this one, we are going to decide what should the E is. E has to be co-prime with the N, and also it has to co-prime with the Euler totals. It means that E, or there should not be any greatest common divisor between the E and Euler totals, or E and the uh, N. Okay, so and then you have to decide what E and what is the D, and D has to be an inverse of the E in the modulo Euler totals. Then you are going to use and this public key and the private key. For E, you are going to use a power of some numbers, and also we are going to use the power of the defined or the target values. Then you are going to use the modular arithmetic here. For example, if in this case, if our x1, if it is, for example, if x1, we found that it is because it is 33, it might be 32 too, for example, right? So it might be the result might be 32. But in this case, you have to apply a modulo 26 in this case. Okay? Because this is 32, but it has to be applied as 26 because there is no any letters in our alphabet. That's why we have to apply 26 modulo again, and we are going to find as 6. So that's it. That's the RSI algorithm, and it is easy to apply. Just follow the steps step by step. Do not be hurry, and don't take it in harsh. You are going to find and you are going to solve all the questions with this algorithm. It is very easy and very easy to implement actually. Sometimes it might be a bit uh, time consuming, let me say, and sometimes you cannot find the exact value. Sometimes it doesn't give the expected results, but you are going to see what are the some constraints of these small prime numbers. If you use small prime numbers, you are going to face with some difficulties actually. Just try to do these all exercises, and also if you wish, it will be better actually. I strongly recommend you to create some secret messages by your own, and create some public keys and private keys by your own, and try to implement your subjects or your words or letters, and see what are the possible encrypted and decrypted messages can be. Okay, so it will be end here, and next week we are going to do, yes, next week we are going to start with permutation and combinations, and then in the second of the new year, second day of the new year, which is the 2nd of January, we are going to make a quiz. What it is? Okay, let me write here. Okay. Okay, guys. There a question? Thank you very much. Oh, Sarah, thank you very much. Okay, guys, have a nice day and wish you all the best. See you later again. Have a nice day too. Thank you.